I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
The podcast that helps you understand the chemistry of your everyday life. Bonus edition.
I'm very excited for this bonus edition. I guess I'm always excited. Maybe I should stop telling people that.
Yes. I mean, they're exciting. Why not?
They're exciting. I think this one's going to be especially fun.
So if you've never listened to one of these Q&R episodes or bonus episodes or whatever, exactly what it sounds like. We do these, actually we've always done the once a month, huh?
Always once a month, but now once a month in place of an episode.
That's right. We used to do them in addition to, and that was a lot of work, and that kind of killed us a little bit. So
yeah. A lot of work, especially as a grad student and a new father. You know?
Yeah. Not so new, but still, yeah, you know. If you've never listened to one of these before, this is where we answer those questions that we ask you guys to send us. If it's not a full-on episode, which a lot of the ideas y'all send, Melissa's like, oh, we got to do an episode about that.
Yes.
If it's not one of those, then we talk about it here. And it could be a quick little correction, or it can be a totally other chemistry question. It could be a question about chemistry career kind of stuff. People have asked about that in the past. And
we're actually touching on that again today.
Nice. And sometimes we get fun, not at all chemistry related questions that we also answer here too.
So true. We have some of those today as well.
Nice.
But before we get started on all of those fun questions, I do actually have kind of a different activity that I want to do.
Okay.
And that's going to make this bonus episode a little bit longer. So if you're expecting our usual 15, 20 minute, it might be a little bit longer. So this is the first episode we ever recorded during Black History Month. We released one, but we recorded it in January. And I really wanted to take that opportunity to use our platform to kind of uplift some Black scientists who have made a difference in everyday life, because our show is all about science in everyday life, right?
Yeah. Yep.
And I really want to do this partially because we learn a lot about white male scientists, and they have done a lot to contribute to the development of chemistry and other science fields for sure. But there are also so many other groups of people who have also contributed to the history of science. But because of the social climate when they were contributing, and because of some of the status quo that just keeps that going now, we don't talk about those people very much. Mm. And I think that kind of does a disservice to those groups.
Yeah, definitely.
But also, I have read studies that actually show that the way we teach science can maybe subtly or maybe not so subtly communicate to students that science is for them or science is not for them. Yeah. And one of those things that can communicate that is seeing role models who look like them being in the field.
Right.
So putting up a lot of the traditional people we hear about a lot, like Linus Pauling and Bohr and all these people who have done really amazing things, doesn't really encourage some of our students that we have in our classrooms today to realize that they can really make a difference and contribute to science too.
Yeah.
So that's part of why I wanted to take time to do this, and also wanted to encourage, if you are an educator, there are a lot of scientists who are still active in doing research that can tie into your curriculum. So putting their pictures up on the board and talking about them as you're going through your unit. I know it's like, who has time to do any of this, because we run through science at such a quick pace in a lot of our classrooms. But if you can find time to do that or work that into an activity, that can actually really benefit your students.
Nice.
And actually, the way I do that is I have an extra credit essay for my students where they can find a scientist that they identify with in some way and write about that person.
Nice. That's cool.
I definitely did not come up with that idea, but I wanted to share. I don't remember where I heard it, but I wanted to share. And I love reading those. I learn about new scientists every time my students turn those in. So very cool.
Yeah, that's awesome.
So today I want to talk about Marie M Daly. She was the first Black woman to earn a PhD in chemistry. And I really wanted to highlight that because I can literally not imagine how difficult that would have been.
Yeah.
Just being a Black person, being a woman, being both of those at the same time. Both of those are disadvantaged groups in science, even still, but back then for sure. And the adversity that she must have overcome and the crap that she must have dealt with just on a day-to-day basis, in addition to all the regular stuff that comes with being a grad student, I just cannot imagine. So I want to just laud her with all the credit. Is laud the word I meant there?
That sounds right to me. Yeah.
Okay, good.
when did she get her PhD, or around when was she studying?
It was in the 1940s.
Okay, cool. Wow. Yeah.
Yeah.
That was a very different time in a lot of ways.
Yes. So she was born in 1921 in Queens, New York. And the first thing that kind of sparked her love of chemistry, her dad had studied chemistry, but because of his financial situation was not able to finish his degree. And then she read a book called The Microbe Hunters about the scientists who started to see the world at a microscopic level. So that was probably so cool to read about.
Nice.
And then she went on to get her bachelor's degree in chemistry at Queens College. And then she was awarded a fellowship to get her master's degree at New York University. And she did that in 1 year.
Wow. Dang.
I know. Gosh. It took me, just for reference, it took me 3 years to get a master's degree.
Yeah. Dang.
The standard time is 2. And I took kind of a different path, but 1 year seems very quick to me.
Yeah, seriously.
Now, schools may have been structured slightly differently at that time, but I'm still very impressed with that turnaround.
Oh, yeah, absolutely. It still would have been, obviously, the idea of calling it a master's degree was a higher level, higher achievement kind of thing.
Right.
I'm sure it was not an easy feat, no matter how different it was.
Right. And then in 3 years, she got her PhD at Columbia University. And all of those degrees were in chemistry.
Nice.
And when she was at Columbia, her research was into how enzymes work on cornstarch, which, if you remember, we talked about cornstarch and enzymes as a way to develop high fructose corn syrup.
Yes.
So it might not have been the same enzymes, but that is still really relevant work to us. I'm sure that is some of the foundational work to getting to be able to make high fructose corn syrup.
Yeah.
Or to understanding how enzymes work with cornstarch.
Yeah. Interesting.
And then also after she left, she got a postdoctoral fellowship. She also did some teaching. So she taught or did research at Howard College, which is still active today, the Rockefeller Institute, and the Albert Einstein College of Medicine. And some of her research that she did after she graduated was helping link high blood pressure and high cholesterol, which is very common in medicine today. Like, people know that high blood pressure and high cholesterol are linked, but she did some of the pioneering work in that with the team she worked on.
Nice.
And there's a paper that she published that had linked cigarette smoking with heart function.
Okay. Yeah.
So how cigarette smokes impacts heart function.
Yeah. Dang.
So that's very cool. I linked to some of her papers that were published with her name on it. So exciting.
Dang.
In peer-reviewed journals. That you can find that on our show notes. But then she finished up with creating a scholarship in her dad's name for students at Queens College who are studying chemistry and physics.
Man, that's awesome.
Isn't that so cool?
Very cool. Yeah, absolutely.
I was very excited to read about her.
I'm especially just, of all those things that are really cool, I have know a little bit more and have seen some of the history behind just how hard it was to start proving some of the connection of health effects, cigarettes and how they affect our health. So knowing that she was part of that is really cool to hear.
Yeah, I was really excited to learn about her. I'd never heard about her before. I tried to find articles on lesser known chemists who have impacted everyday life. And she was on a list from the Chemistry and Engineering News article put out, I think, last February. So I also linked to that as well.
Nice. Very cool.
So thanks, Dr. Daly, for all the cool work that you've done and for literally blazing the path for Black women studying chemistry. I feel like the work that you did in that way can never be highlighted enough.
Yeah. And thanks for telling us about her, Melissa. That's awesome.
Yeah, of course. All right, now let's get into the listener questions.
Okay, so this first question is from the username Boudreaux B. And they asked, when something stretches, what's happening at the molecular level?
Okay, so I briefly looked this up and I could not find any satisfying answers. I think they asked maybe in a message previously sent if bonds are breaking, but I don't think That's not my instinct, because if you zoom into the molecular level, atoms are very small and they're held together, like next to each other, by intermolecular forces, right?
Yeah.
Well, I guess molecules are very small. Atoms are held together by bonds, and then molecules made up of atoms are held together by intermolecular forces. So my guess is that there could be increasing space between the molecules as the work is happening to overcome those intermolecular forces. So imagine like silly putty stretching apart.
Yeah.
You may be slowly overcoming the intermolecular forces that are holding together piece by piece. You're creating enough space until it's not attached anymore. I would be surprised if you were physically breaking bonds, because you'd have to be breaking bonds and forming new bonds is a chemical reaction. So I think it's more of a physical change of the molecules physically separating than the molecules changing.
Oh, yeah. I see what you're saying.
Now, the one case where I think that might be different is in the case of breaking apart something like a salt. A salt is a lattice, so it's held together where a lot of ions, like positively charged ions, are surrounded by negatively charged ions, which are surrounded by positively charged ions, which are surrounded by negatively charged ions.
Yeah.
So that's an ionic bond. And if you break off a piece of salt, you're breaking off a piece of that lattice. So I would think in that case, you are overcoming the ionic bond, I think.
Yeah.
But I don't know for sure. That's my chemistry off the cuff.
Nice. That is very interesting. Very good question. Kind of reminds me of like whenever I asked about what is stickiness, you know?
Yes.
It's like that kind of thing. Like, what is stretchiness? What is really happening at the molecular level? That's cool.
Yeah, I think it's space between the molecules by overcoming intermolecular forces. That's my thought.
Nice. Good question, Boudreaux.
That is a good question. I really liked that a lot.
This next one is from Andrew L. And Andrew asked, why do you think there is a strong stigma associated with OChem? Now, I know you don't have like strong opinions on this, Melissa, at all. So if we need to skip this question and you just, that's totally fine. No big deal at all.
Well, guess what? I don't want to skip this question.
Okay. Yeah. Okay. Whatever. Yeah. What do you want to do?
So, Andrew, this is my area of research, which Jam knows. So that's why he laughed at me. I wish I could tell you everything about what I have researched about it, but it's currently submitted for publication. So if and when that is accepted, I will be able to summarize my research without fear of being plagiarized or someone else trying to like kind of scoop me, basically. But in the meantime, I can tell you what I think and not what my research has found. For one thing, I think OChem has this reputation around it that it's really bad, and somehow this has spread beyond just chemistry. And so the way people feel about what they're learning, for example, fear of a subject that's been told is very hard, that can impact their learning experience.
Yeah.
And so I kind of think in some ways that is perpetuating itself, right? Like we've heard that OChem is going to be really hard, so we think it's going to be really hard, and then we get in there and we're scared, and so we're not functioning optimally because we have a lot of anxiety and fear around it, and then we don't do well, and then we tell other people that it's really hard.
Yeah.
So I think that's part of what it could be, but really our feelings do affect our learning experience. Like if you can think of a subject that you loved and how you approach that versus a subject that you dreaded and how you approach that, you're much more likely to have a positive learning experience where you actually are creating new knowledge in your mind than if not.
Yeah. That makes sense.
And that's a whole learning experience or a whole learning theory called meaningful learning based on, his last name is Novak. I can't remember his first name off the top of my head, but he created this learning theory called meaningful learning. Students have to choose to integrate knowledge as part of their learning process. And if they're not interested or they don't have positive feelings towards it, they're less likely to make that choice. That's part of it. The other part of it is I think the class is not taught well. So we have developed these ideas about what students, quote unquote, need to learn in order to be successful in their next class. And I think that minimizes how much they experience of the scientific process, right? Where they're making observations and trying to figure out why the things that we're observing happen the way that they do. And it's not often related back to everyday life. It's like just a bunch of reactions thrown at you that you're expected to know, and then you leave the class and it never comes back in.
Yeah.
So that is part of why I made this podcast, is because I believe it's taught in a way that's unhelpful. And so I want to change that. And that's also some of the research I'm doing. And other people have similar research. So one thing that's emerging is something called systems thinking, where we teach chemistry concepts by looking at a big picture problem. Like, okay, climate change. What's all the chemistry concepts that we can teach that connect to this system? Rather than just teaching isolated facts that don't connect to each other and don't feel as if they have any real world experience.
Yeah, that makes total sense.
And then the last thought I have is that it's a lot of work. It's just really hard to learn organic chemistry. Even if you have an incredible teacher, if they're sticking to this curriculum that we've been told we have to teach and they're going at the pace that it goes at, a lot of times that's difficult to keep up with. And also learning organic chemistry, because you have to learn all of these like shorthand symbols, is kind of like learning a new language, and then immediately you have to start speaking in the language.
That is a great analogy. I've not thought about it like that, but that makes total sense. Why it'd be so hard then, you know?
Yes. Yeah, it's really difficult. And there's even a book called Organic Chemistry as a Second Language. But if you think of it like that, I think you can have a little bit of grace for yourself. Like, oh, this is hard.
Yeah.
So it's going to take a lot of work. That's part of how it gets all of its reputation. But if you go in thinking this is hard, it's going to take a lot of work. It is relevant to my everyday life, though, and I am capable of doing it if I put in the work. I think students would have a better experience than just the fear.
Yeah.
So I try to address that with my students at the beginning of class, but it's hard.
Yeah.
So those are all my thoughts on why it has a stigma associated with it. But once my paper gets published, I could tell you all about that. And really, I could talk about the stigma associated with OChem all day.
Nice.
So.
Yeah. So that's a little teaser, sort of, in some ways.
Yes, it is a teaser. It's been very hard for me not to talk much about my work now. I'm very excited for when I'll be able to do that.
Yeah, definitely. We are too. So this next question is from Katie H. And Katie asks, why do I feel like I'm buying better water when it has a higher pH?
So I have heard a few people ask me this question. And first I want to say, what does it mean when you have higher pH water or alkaline water? Those mean the same thing. And pH is basically just a measure of hydronium ions or H plus ions, or basically protons without electrons attached to them in water. And the more you have of those, the lower your pH, which I know that's kind of counterintuitive.
Yeah.
And then the less you have, the higher pH, and it's actually more basic. So basic is a bigger pH. They both start with B, and it has less of those H plus ions floating around, or hydrogen ions, protons, whatever you've heard them called, all those things.
Yeah.
But honestly, I don't think it is better water. I think there is a marketing campaign that wants you to think that, and they've been pretty successful, but I've found a few research articles and I linked them below, and none of them have conclusively shown that it does anything positive in your body. However, I think there is one thing that it could change, and that is the environment in your stomach and your gut. So your gut health matters a lot for your overall health. There's a lot of bacteria in there and they need a certain environment, but I believe that your stomach acid exists to kind of help regulate and make sure it is at the right pH.
Yeah.
So I think your stomach might neutralize that out either way. The other thing I've thought is if you have an acid stomach regularly, so a lot of times I've had damage previously to my stomach lining, so I just tend to get like burning in my stomach, where basically my stomach lining can't handle the acid that's present in my stomach.
Yeah.
And I'll take Tums, which if you want to learn more about how that works, we have a whole episode about it.
Yeah.
But I'll take that and it cancels out some of the acid to relieve some of that burn. And I think higher alkaline water could actually help me with that. Like if I know I'm going to have ceviche for dinner, which is tons and tons of lime juice, then maybe I should drink alkaline water with it.
Yeah, right. I see.
But other than that, I don't see how it could improve your physical health. Now, something I also don't know about is, does it taste better? And I think, Jam, you mentioned there was something you want to talk about with that.
Yes, totally. So obviously, you know, the only thing I can really bring to the table is, does something relate to coffee or not? And if it does, then I probably have thoughts on it. So
That's hilarious.
I have used alkaline water. I forget the exact pH that I had used for a little while. I tested for about 6 months using it with coffee. And this is a couple years ago. And I also talked to a Q grader that I know that is basically the same equivalency for like being a sommelier. You have to like pass tests and stuff. So I know a Q grader. It's a very difficult process. Basically, you have to have like be able to prove that your palate is accurate, which is so hard to think about.
Yeah, that is hard to think about. And accurate to what?
Yes.
Like some objective standard.
Yes, exactly. And it's like, and sometimes they'll do things to the coffee to make you, that they know they did, and see if you can taste it. So that's one of the ways they do that.
So they're trying to trick you.
Yeah, they'll taint coffee sometimes and see if you can pick up on it, stuff like that. All that to say, this is only one Q grader. I talked to him about it, and he said that in terms of flavor, not for health reasons or anything like that, that he thinks there are specific coffees that are more on the acidic side, that using alkaline water would really help the flavor. And he has seen that to be the case, not just like hypothetically, but in he's used it a few times and has found that to be a good thing. So,
that makes sense. If it's very acidic coffee, that the basicity of the water can counteract some of the acidity, which I think acidic foods are usually sour and basic foods are sometimes more bitter. So I could see that. Like, I have heard, although I don't know this for a fact, that fish is more basic because it has some ammonia in it. And we like lemon on it because it neutralizes some of that basicity.
Yeah.
So a similar idea that it can neutralize some of the unwanted acidity in the coffee.
Totally. And it obviously brings up, you know, tons of questions about what level of acidity and basicness in a food. Basicity, yeah. In a food, what amount of that can we actually taste? How much does our taste buds pick up on that? Because coffee, one coffee to another, they may be even roasted really similarly, and one may just taste a lot more acidic. That's tough to really parse out. You know what I mean? But he did confirm that he thinks that there is a flavor benefit for acidic coffees.
So there you go. Maybe that's why you feel better.
Yeah.
I personally drink water from the tap. We do have a little filter that we put it through in our fridge. Mm-hmm. But sometimes I just still only use it from the tap. I don't know if that makes me terrible or not, but that's what I do.
Yeah. Yeah. That doesn't make you
Feels
terrible.
better for the environment,
you
know?
Mm-hmm. Makes sense.
And I'm fortunate that the water that we have tastes fine and is safe to drink.
Yeah.
So I have that privilege to be able to drink water from the tap confidently. So I don't usually buy bottled water.
Yeah.
But I have heard that sometimes certain bottled waters are literally just tap water bottled.
Yeah.
So really check things out and see what you're buying. And if you're buying alkaline water, really ask yourself why you're buying it. Is it for the taste, or is it for what you think might be health benefits that aren't proven yet?
Yeah. That's good. So this next question is from Sheeran, I believe that's how it's pronounced. If I mess it up, I'm very sorry. Sheeran asked or said this: honestly speaking, I'm really interested in chemistry, even if it's difficult concepts, but I'm afraid of sticking in the lab for the rest of my life. For this reason, I have no desire to continue my passion in the field.
Okay, that totally makes sense. I also didn't want to be in the lab for the rest of my life. One, because it's not the safest, healthiest environment to be in day out, especially if you're a woman and you want to become pregnant at some point. That kind of adds new complications that you would have to plan to deal with. Women can for sure work in lab long term if they want, but that just wasn't something that I wanted to deal with.
Yeah.
So here are a list of chemistry jobs that you can do with a chemistry degree, even outside of a lab. Research in a lab is one of them. You could teach. You could be a chemistry tutor. And if you're really good at it, you can make up to and above $100 an hour. You could be a science communicator. That's what I want to be. You can be a science journalist. You can work in any area of the medical field helping people. You can work in a forensics lab. You can do pretty much any job that requires you to have some kind of problem solving. So we have a friend who got a degree in chemistry, and actually now he works in app development.
Yeah.
Because you develop skills in problem solving and thinking critically and observing things that many people need you to have to be successful in other jobs. You can work in the field. And what I mean by quote unquote in the field is there's a lot of environmental jobs where you have to go out and test water or things like that. So you can work in a job where you'll be out of the lab working in the field. A lot of like marine chemists that I know from my sister's career have jobs where they're in the lab some, but they're also like on boats a lot.
Nice. That sounds cool.
If you learn more about the education side, you can go into curriculum planning and management, and you can also educate educators on how to teach chemistry well. There are lobbyists who need to have a good understanding of chemistry. You can also go into patent review. So if you are interested in law, you can get a degree in chemistry and a degree in law, and you can review patents for a job. And from what I've heard, make a ton of money. And you can also get a higher level degree in chemistry and work on patents without the law degree, I think.
Interesting.
You can be a data analyst if you work in one of the areas of chemistry that has high levels of data to be analyzed. You can do food science, which isn't a lab, but kind of like a really cool lab setting. You could do cosmetic science, which again, lab, but kind of a different lab setting. You could work for an oil company and make a lot of money, although you might have problems with your morals because of all the stuff we learned about plastic. So be careful if you're going down that path. So chemistry is really everywhere. Those are just ideas I thought of off the top of my head. Having a background in it will help you in so many fields. We know a chemist who, I think, was it a chemist or his parents were chemists who ran a coffee shop, and he used his chemistry knowledge to inform his coffee brew.
Yeah, his parents were chemists. Exactly. Yeah. Mm-hmm.
Yeah. So really chemistry helps you anywhere you are. So if you're interested in chemistry and you need a college degree, that could be a fun one that would challenge you to think more and give you the tools to be in a lot of different spaces.
Awesome. There's a lot of great options. Very cool.
I thought they were good options.
Yeah.
I was like, wow, wow, I'm excited how many I came up with.
This next question is from Gracie, and Gracie asked, what advice would you offer to college-aged chemists?
And Gracie is a UNT Eagle, so go Mean Green, Gracie.
Oh, nice.
There's a lot of advice I have for any college student. For any college student, I think it's okay to get enough sleep. It's important to get enough sleep.
Yeah, for sure.
And if your schedule doesn't allow it, you need to consider what to take off your schedule or how to manage that better so that you can sleep. I thought I didn't have time to sleep, but what I actually was doing was wasting a lot of time in college. It's also okay to change your mind about what you want to do. So I thought that I wanted to do organic chemistry research. And then the more I did that, the more I realized I wouldn't be happy in that long term. And so I switched gears and stopped my PhD at a master's level and changed programs and started back over at the age of like 27 or 28. So I think some people think it's too late for me to change my mind, but it is never too late for you to move closer towards doing something that will bring you joy long term. And I think you should make friends in any job that you're in any class that you're in, any opportunity you have to make friends and study together. That will make your college experience a lot better. And honestly, after watching my mom get sick and pass away, her coworkers were there, but her actual work was not there. So it's really more about the way that you care about the people around you while you're doing the work that you're doing, I think, long term in our lives, rather than the work that you're doing. I think being a good worker is important, but I think having friends while you're doing the work is also really important.
Yeah.
And then for chemistry specific, I think you should do undergraduate research to see if that's something you want to do. And there's a lot of cool opportunities. I actually talked about this on my TikTok. The two main ones I know is you can do undergraduate research at your university, or you can do something called an REU, which is a research experience for undergraduates. It's funded by the National Science Foundation. I think it might only be open to American citizens or students studying in America, but you can go anywhere in the world to do it. And you basically get paid and your living expenses covered to do science for a summer. And it's incredibly cool.
That sounds awesome.
Yeah, it's very cool. So do undergraduate research so you can see if you would want to be in a lab long term or be exposed to other things and develop new skills and learn about how people live in other areas.
Yeah.
Any other advice you'd have for college student, Jam?
I think this has come up in a couple of Q&Rs in the past, and I can't remember exactly what I said in the previous ones. I probably had a little bit more time to kind of think of a response, but I would kind of reiterate what you said about time management. I think it behooves any student of any, major or whatever degree you're in, to find out what works well for you to manage your time well. If it's like your digital calendar or a paper one or whatever, block out time for things. For one, just for studying and homework, stuff like that. Don't leave that late, obviously. But then also block out time for fun and for sleep and for reading for fun and things like that. Just be a person who becomes good at managing time, not just so that you get all your homework done, but also so you make time for the things that are good for your mental health and for your physical health. I think it's really important to find a thing that you can do physically that you enjoy. And sometimes the positive effect on your mental health from that is huge. So when you're
kind of gives you time back almost.
Exactly. One year I decided to take a racquetball class because it was a semester that I don't remember why for some reason, but I had to take classes in a specific order in my program. And so I had a slightly lighter load one semester and added a racquetball class. And obviously I could have just gone and played racquetball on my own anyway, but I wanted to learn it better. And it was so fun. It was great. I made some friends in it. It was good for me. It was kind of cool to have something built into my schedule every week where I had to play racquetball for a class, So things like that I think were really important for me in my college experience. And friendships, like you already said, Melissa, were absolutely huge. I had some friends within my major, and I tried really hard also to make some friends outside of my major too. And just both of those things really helped sustain me through my college experience. So, yeah.
Yeah. While you were talking, that kind of reminded me that I think your mental health is more important than your grades. And so if you're at a crossroads where you feel like you're working so hard at school that your mental health is suffering, I think you need to take a step back. And if that means delaying a semester or taking a lighter load, if you're able to do that, that's okay and good, and you should. And the other thing I thought is you will likely fail at things, and that does not make you a failure.
Yeah.
You're going to have some of the hardest classes you've ever had, and some of them are not designed well, and some of them maybe won't have the best teachers. It just depends kind of, but you aren't a failure because you've experienced something new and difficult that you weren't good at right away, and that's okay. And if you really love the work that you're planning to do, it's worth it to push through that failure, I think.
Yeah.
So those are my thoughts. Good question, Gracie.
Yes. And I'm hearing right now, if you can't see me guys, but I'm touching my ear like a newscaster would. I think we have another correspondent on the line who might have a thought or two on what helped them in their college season. Is that right, Melissa?
Yes, I think here with me, just walked into this space, is Mason K. Mason got his engineering degree from West Texas A&M University in Canyon, Texas, and he wants to share some thoughts on how to be a good. I've lost my newscaster voice. Mason, what helped you be good in college? What helped you succeed? What advice would you give to an undergraduate student?
This is a lot to think about on such short notice. When you're studying for tests, what I used to do is kind of split it up. So don't try to cram all the night before. You want to spread it out a little bit. And if you do decide to cram the night before, you're going to want to study both in the night and then go to sleep, get your sleep,
Mm.
and wake up in the morning and study again that morning.
Mm.
Like refresh the things, like go over what you thought you didn't do as well at the night before, and refresh your mind on that stuff.
That's actually supported by learning theories that you learn better if you do a little at a time spread out
Yeah.
because you interrupt your forgetting process regularly. And sleeping helps you perform a task better. So I tell my students if they're going to pull an all-nighter, please do it 2 or 3 days earlier and then sleep before the exam. But really, I beg them not to pull an all-nighter because it is not worth it for your long-term mental health. I think not sleeping enough is part of why my body doesn't function well, because not sleeping, your body interprets as being under attack and it activates your immune system.
Yeah.
Fun fact. Learned it in a grad student presentation I did. Okay, well, thanks for that input, Mason. You're a good correspondent, and we're going to get back to our Q&R.
Bye, Mason.
Bye, everyone, and Jam.
So this next question is from Renee C., and she asks, what would you do if you didn't have to work?
Well, Renee, I would do the same thing I'm doing now, except I wouldn't be looking for a job after I graduated. I would just, instead of doing graduate school teaching and my podcast, I would only do my podcast. That would be the dream, is do this podcast. And then I also have a TikTok where I make fun chemistry content, and a YouTube where I actually do more OChem course material. So I would probably just do those and then go to beautiful places and spend a lot of time in nature, like with trees and ice and lakes.
Nice.
What about you, Jam?
I'm in a similar boat in that I think a lot of the things I currently do would not change, to be honest. Maybe...
I know what would change.
What would change?
If your wife didn't have to work.
Yeah, definitely.
That would be the dream for you.
If my wife didn't have to work, for both of us, that would be the dream. She would have a much more interesting answer for this. But one thing that would be a natural result, she'd get to spend more time with our son. And that would give me a little more time also to do things like the podcast and the church stuff that I do as well. So there's a few ways that would give our life just more elbow room. But what's cool, I think, is that I have tried really hard to make room as much as I can, even though, it is hard, for the things I want to do that aren't, that unfortunately don't make money or don't make very much, and try to have that be I try to have that be a part of my life no matter what. And that's partly just because I want to, and it makes me happier and all that stuff. So, yeah.
Yeah. I think we're both lucky that our jobs are passion projects.
Yeah, definitely.
But I also think we're both lucky that we entered into a financial lifelong agreement with two people who support the income of our homes.
Yeah, definitely so. And have a really stable situation and all that stuff. So, yeah.
So that helps us both to be able to do that. So we're both very lucky to be able to answer that question that way.
Yeah, 100%. Have a way of having something you really love be part of your life. If it's your job, huge bonus. If not, then make it fit in there somewhere.
Yeah, definitely. That's a good thing to say.
Yeah. If you love sewing, then find a way to make sure you can sew sometime.
Ooh, I'm taking that on as a hobby, actually. I just bought a used mini sewing machine for $40, and I'm very excited.
Nice. Awesome. Totally random out of my head. I just thought that's something that some people can make a career and some people can just do for fun,
Mm-hmm. That's a good one.
Yeah. Or roasting coffee, you know what I mean? In my case.
Roasting coffee,
totally just one of several things that I do that don't make me very much money, but are fun, and I enjoy them. So.
Yeah.
Yep.
Well, I think our very last question is also from Renee C., and I am very excited to answer this one.
So Renee C. asked, why didn't you use my question last time?
Okay, Renee. She's my sister, so that's more of a sister type question.
Yeah.
But there might be listeners who are also wondering that who are not my sister. So for those of you who have that same question, it's very hard to answer everyone's questions. We try to make these episodes mini. short and bite-sized, easy to take in. Also, sometimes people ask questions that require a whole episode to answer.
Right.
For example, someone asked about the chemistry of tears. That's not a Q&R type question.
Yeah.
So those are the two reasons, but we do read all your questions and we are excited by all of them.
Yes. And sometimes so many come in that we don't have a chance to, even though we try to tell people, thanks for your question. That will probably show up in some way at some point in the future. Maybe it's a full episode. And so that's just the downside of this not being our main thing. Sometimes we get Instagram stuff, email stuff. We noticed in that message on Facebook we hadn't realized was there, sitting there for like a month. So stuff like that. We definitely want all your questions, and you guys send such great ones that sometimes there's just no way to fit them all. So.
And sometimes we start recording before the timer has run out on the Instagram story. So sometimes people send in their questions later than our recording date. That's on me. Yeah. I post the Instagram stories late sometimes. But we are really thankful for all of our listeners who send in questions. And we're really thankful for our listeners who support us on Ko-Fi. And for those of you who don't know, that is our digital tip jar, where if you want to help contribute to the show or help us expand our equipment or do other new cool things, like recently we've been able to release transcripts of every episode so that more people have access to the information, is very exciting. Yeah. So thank you so much to those of you who have supported us in that way.
And those people who are either monthly givers or have given since we thanked one-time givers last time are Chelsea B., Christina G., Nate S., Hunter R., Jacob T., Emily C., Timothy P., an anonymous person, but you know who you are, so thank you, Stephen B., Alyssa Os or OS, I'm not sure how to pronounce that, Derek L., and Julian E. Thank you guys so much for helping keep our show going. We love to be able to make the show free for everyone, but obviously the cost of making it is not free, unfortunately. So thank you guys for helping us bring this podcast to everyone and bring chemistry to everybody's lives.
And I especially want to shout out Emily C., who's a fellow chemistry instructor, who wrote us a really nice message. We really appreciate that, Emily. Thank you so much.
This episode of Chemistry for Your Life was created by Melissa Cleaney and Jam Robinson. And we'd like to give a special thanks to E. Robinson, who reviewed this episode.